Okay, hi guys. So in this lecture, we'll be continuing on seeing some more of the examples of reaction of compounds with or ketones, specifically with Mg in presence of water. Okay, so let us take some more examples. We have this, and we are reacting it with Mg in presence of Hg and water. So what would be the compound formed? We would have something like, again there will be a free radical here and the formation of O negative here. Again this will dimerize with one free radical here and O minus here. So what will happen is we would have a dimer form like this, and we would have OH like this. Okay, how OH is formed? Because O minus attacks on the water molecule. Okay, plus obviously Mg OH whole twice is formed, but that is of less importance for us. Okay, let us discuss what happens in this reaction. We have something like this, and again we have Mg Hg and water molecule. Again what will happen is dimerization will take place. The O double bond O will convert into OH, and this product would be formed. Okay, let us consider a third example where we have, let's say, this compound, and again we actually heat it in acidic medium. So what will happen first is we'll get something like a, this is obviously a Pinacole, so we'll get a Pinacolone. So how would that reaction take place? Obviously this OH minus will take on this H plus. It will get a positive charge here. Now what will happen next is we'll have some migration from substituents attached to this carbon atom, and we know that the order of migration is something like this, and in the last comes CH3, hence pH would be the first one to be getting migrated. Okay, so what will happen is pH will migrate over here onto this. OH will get released as a water molecule, and this carbon will get a positively charged, and this would be highly stable. Why? Because of formation of our IIT cation. So finally in the intermediate state this would have a positive charge with CH, OH, C, CH3 and two phenyl rings attached to the C group, C atom. Okay, by the way, this is the order of migratory aptitude. Okay, so now on this again our oxygen will form a double bond with this carbon atom, and H would be released. So we would get something like this as our final structure, and CH3 over here. Okay, so this would be the final structure formed. I hope you are able to follow my steps which I told you orally, because we have done so much practice over that it should be directly running, all the steps should be directly running in your mind. Okay, OH, and again in presence of H plus we heat it. Again what will happen, you can select any of the carbon atom to form a positive charge because both are identical. Then what will happen is we have a CH3 group here, and we have a ethyl group here. So what will move? Obviously Ca2H5 is having better migratory aptitude than CH3. Why? Because it has more plus I effect. Because of one more CH3 attached, it would give more stability to our positively charged intermediate carbocation ring, or positively charged ring, 3 carbon member ring that will be formed at this carbon atom. Okay, The three-member ring would be this carbon, and this carbon. Okay, so what would be formed? Finally, we would have something like positive charge at this carbon atom, OH here, and we have something like this. Again, we will have the formation of ketone. Okay, so we would have something like, so this would be the final product formed. Okay, now let us look at another example where we have something like this. OH and CH3. Again, in acidic medium we are heating this compound. Then what will be the final product? Again, this oxygen would attack on this, form a positive charge here. This H atom would actually shift because H is having better migratory aptitude than CH3. I hope you remember the series. H will shift here, it will get a positive charge, then lone pair of oxygen will come into the picture. Okay, the whole story repeats itself. We will get something like this structure, CH2 CH3. This would be the final product formed. Okay, let's look at another example. We have something like this ring, double bond O. First we reacted with the MgHg, and second we can also react with the Al2O3, but I am not writing it. I am directly writing in the presence of water molecule. So what will happen is dimerization of actually this carbon atom will get a free radical on itself, and O minus would be there. This will be a free radical. This will rather combine with another compound, so they will form a bond in between. Okay, and these two will actually attack on water molecule to have OH attached to themselves. Hence Pinacole is formed. Now if I say that you are again supplied with H plus and you have to heat it, then you have to form a Pinacolone. Okay, so I hope you remember the concept of ring expansion. Just think whether this concept would be applicable here or not. If it's applicable, then your final product would be something like this. Okay, so I will leave this as a homework part for you. Okay, now let us look at another example. We have something like this. And CH3. Now what will happen is we again pass magnesium in presence of water. In this case also, what will happen is we will have something like this, O minus or dot here, CH2 CH2 CH2, 1 2 3 4 and 5, and CH3. What will happen is these two free radicals will dimer between themselves only, so intermolecular dimerization will take place, in which we will get something like this, in which we have OH and CH3 at adjacent carbon positions. Okay, so this would be the final product formed. Okay, so let us take the last example for this lecture. We have something like this, C plus, and we have CH3 over here, and again we have OCH3 here. Okay, again this positive charge will like to move on to this carbon atom. Why? Because of the formation of highly stable IIT cation. We have discussed this so many times, and if you want this positive charge to come on this carbon, either pH group, the phenyl ring, or toluene substituent has to move. And which other two will move in this case? Obviously this compound will move because it's having more plus high effect because of the presence of CH3 group also, which will actually increase the stability of 3-member intermediate carbon ring. Okay, so what would the final product look like? we would have something like this. CH3 group here, we have a phenyl group here, and we have a OCH3 group here. Okay, and this would have double bond and pH. Okay, so I hope you were able to follow the examples in this lecture. I went too fast intentionally because I want all of you to think slightly more faster and clearer, because we have seen so many examples. So now is the time to directly write the products from the reactants. Okay, so with this we end this lecture.